Hello, welcome to Rebar Detailing 101. This is the first video lesson on rebar detailing as practiced in the United States. Our main topic is the Manual of Standard Practice 2009. I recommend that you all read and understand the MSP from cover to cover. For emphasis, I created this video to highlight what bar lines consider very important. I hope my commentaries will help you remember them. This video lesson, of course, can be watched over and over again at your leisure. Our first topic is imperial, metric, and sub-metric bar sizes. You'll find everything that we talk about inside this MSP. Sub-metric bar sizes versus inch-pound bar sizes. This is sub-metric against imperial. The United States is the only one using imperial bar sizes. All other countries, including the Philippines, are using metric bar sizes. To catch up with the rest of the world, in mid-1990, the U.S. federal government mandated the conversion to metric bar sizes on all federally funded jobs. Some of the states complied and applied the conversion on their own very own state-funded jobs, but still many states and all of the privately funded jobs did not. The U.S. was facing the prospect of having two inventories of reinforcing steel, one in metric and one in imperial. To avoid this, the mills, under their own initiative, proposed to supply metric bar sizes in sub-metric bar sizes. What does it mean? Sub-metric implied that it's not quite metric, but close enough. Sub-metric bar sizes are exactly the same imperial bar sizes with the new markings in equivalent metric size. Let's examine. These are all the imperial sizes the United States use: 3, 4, 5, 6, 7, 8, 9, 10, 11, 14, 18. 11 bar sizes. What the mill did, they created the same bar sizes but marked them with their equivalent millimeter size. So at number 3 measured very close to a number 10 millimeter. So they call that number 10. Number 4 is 13, 16, 19, and then on and on and on like that. Still, same bars, 11. So sub-metric rebar equal to hard metric rebar. For example, Canadian metric bar sizes are 3 bars sizes less than the US. Let's see if we have the Canadian bar sizes. Here is a copy of Canadian bar sizes. Let's see if I could enlarge it. Pretty close to what Australia is using, what Europe is using. The sizes are only 8 bar sizes: 10, 15, 20, 25, 30, 35, 45, and 55. That's the millimeter dimension of the diameter of the bar. You notice that when they created these bars, they went into increments of 5, 10, 15, 20. Meanwhile, the sub-metric ended up, because it wasn't designed for metric, ended up with odd sizes like 13, 16, 19, 22, 29, 32, while a true hard metric is 10, 15, 20, 25, 30. And only 8 bar sizes. Less inventory means less cost. These 11 inventories. In the US, bar sizes outside the United States are referred to as hard metric, which is the true metric. The key word then is sub-metric for the US and the rest of the world hard metric. Sub-metric, hard metric. Go back and replay this if this is not yet clear. But I'm just cautioning you that as you get your own job, you will come up with sometimes a job that is designed in metric. Everything, the dimensions of the concrete is in metric. The bar sizes are in soft metric. These are the soft metric. There are no hard metric bars available in the United States. Alright. Our next topic is ASTM specs and grades. This one. In rebar detailing, the first responsibility of a rebar detailer is to determine the rebar specs and grades used in his assigned job. That's the first thing he has to determine. How important is this responsibility? Several years ago, a detailer made a mistake of ordering 3 loads of reinforcing steel for a Caltrans job with the wrong ASTM specs. Caltrans stands for California Department of Transportation. While the iron workers were unloading the rebar, the state inspector noticed that the tags indicated the rebar are ASTM A615, this one, instead of ASTM A706. Immediately, the state inspector ordered the bars sent back to the fabricating shop. He refused to allow them to use those bars in that particular job. That error cost the fabricator almost $60,000, 3 loads of rebar, or an equivalent of 2,520,000 pesos. If Barlines was the detailer on the job, Barlines would have been back charged by that amount. That is how important this responsibility is. So every time you make a detail, and you're making an order, a bar list to send to the shop for fabrication, check and double check that you have the right grade. Because even if you have the right quantity, the right bar sizes, and the right length, but the wrong grade, they will not be able to use the rebar. In this table, across the top, the ASTM specs, the column for that, the bar sizes available, the grade, the minimum yield strength, and the minimum tensile strength, and other properties. Most important thing is ASTM. What belongs to ASTM? It comes in grade 40, 60, and 75. In grade 40, the bar sizes are number 3 to number 6. In grade 60, it's number 3 to number 18, which means all the bars. Same thing with grade 75, all the bars. The most popular ASTM spec is A615, and the most important popular grade is grade 60. Grade 40 are hardly ever used now, but still they are available. They limit production of the grade 40 to number 6. Low alloy A706, which is this one, are specified in seismic zone 4 and for bars that are welded. It has a low carbon content, which makes it ideal for welding. So it's either used for welding or for zone 4 use in ductile frame, moment frame design. Anything for seismic, you use A706. Seismic zone 4 in the United States is along the Pacific Rim of Fire. States bordering the Pacific Ocean, California, Oregon, and Washington. Stainless steel A955 are specified as an extra protection against rust. Stainless doesn't rust. For jobs near the ocean, as an extra protection against rust, they specify stainless steel A955. You can imagine how expensive this is. All these grades, this is grade 60, the popular one. Low alloy is a little bit more expensive than the A615, and the stainless steel is more expensive than the A706 and the A615. Once again, it comes in grade 40, 60, and 75, and the bar sizes are here available. 3 to 6 also, 3 to 6, 18, 6 to 18. Low alloy steel, 318. It doesn't come in grade 40 or grade 75, it only comes in 60. So this table will help you determine exactly the properties of all these grades. So the important thing is learning and knowing and determining that your job falls either one of these three categories. There are other ASTM specs available for bars than this table shows. For example, it doesn't show here, and it's available in the United States, a rebar called MMFX. MMFX. So let me just see if I could write that down so you will remember. The bar is MMFX. Let me capitalize that. MMFX bars are specified as an extra protection against rust. There are other new bars being developed now with higher tensile strength. It's not listed in this. Overall, however, chances are the rebars in this table are all you are going to encounter while you're detailing. What are the other most common ASTM specs? This is another important item here. I think I found it. Epoxy coating. For rust protection, rebar are sometimes epoxy coated. The type of epoxy applied falls under different ASTM specs. A775, let's see if I could highlight that. A775 are green colored epoxy coating, and this is applied before the rebar is bent. So while they're still straight, they apply the A775 epoxy coating. After it has dried, then it goes to the bending process. The next one, let's see if we could just pull this, is that's A775. Save the highlight by going like that. The other one is ASTM A934. A934, the color is purple. The epoxy coating is purple, and the coating is applied only after fabrication. Because it's a hard coating, it's a heavy coating, they make the application of the epoxy after it is bent. It costs more to epoxy coat in A934 because the bars are already have a shape in them, and sometimes they're quite long, so they're hanging up in a rack while they're applying this epoxy coating. While the A775, the rebar are not yet bent or fabricated, they're still straight, so it's just flowing on a conveyor belt. This one though, it's not, it's already fabricated. The next item for rust protection is of course zinc coating, which is ASTM A767, galvanizing, zinc coated galvanizing. So these are the three types: A775 for green, A934 for purple, and for galvanized is A767. You need to know the grade of steel, which is A615, A706, and then you also need to remember this: the green coating, A775, or the A934, which is the purple. These are the most important ASTM specs that you must remember, because if you have the right bar size, the right length, the right bend on your detailing, and the right grade, but you sent the bars to be epoxy coated A934 when actually all they wanted was A775, then it would have cost you a little bit more money. So it's important to know exactly what coating is needed according to your job, according to the specifications of your job. Let's see what else. There are other ASTM specs for rebar, which was not shown on the table, which is rail steel. Rail steel is A996. Rail steel are popular only in certain parts of the United States with an abundant rail steel scraps like Pennsylvania, New York, and Chicago. The steel mill used to be all in Pennsylvania, so you get a lot of rail steel. That's the one they use for railroad tracks. You know, they have a lot of those scraps, so they melt them down and they make them into rebar, so they call them A996. Okay, the next item we're going to talk about are welded wire mesh. Let's see if we could find that. Again, if you have this book, this is available to you. You can make a copy of this book. Get yourself a folder, a 2-inch folder, a 3-ring binder, and make yourself a book. So that way you could refer to it. This is wire mesh. The style of, they call these the style, which is denoted as like 6 by 12, W16 by W8. This is called the style dimension. 6 by 12. The first two numbers denotes the spacing of the wires. The first, the longitudinal wires, the spacing of the longitudinal wires. And the second number, the spacing of the transverse wires. And then dash. And then the next two numbers, W16, denotes the area of the steel for the longitudinal wire in hundredths of an inch, and the last number is the area of the steel of the transverse wires in hundredths of an inch, square inch. Plain wires are denoted with W. That's just plain wire. In metric, they refer to it as MW, so metric plain wire. If it's deformed, then they refer to it as a D16 by D8. So if you see the letter D, that means the wire is deformed. MD would mean metric deformed wire. You could read through all this. So the size indicates the cross-sectional area of the wire in hundredths of a square inch. From time to time, you will come up with styles in the old formats, such as 6 by 6, 10, 10. A long time ago, the wires was denoted by its gauge. So 6, 6, 10, 10 would mean the spacing of the wires is 6 inch by 6 inch, and the size, the gauge of the wires is number 10 and number 10. If you remember measure, the higher the gauge, the smaller the wire. For example, a number 6 gauge is larger than a number 10 gauge. Because of this, they converted it into sectional area of the wires. A lot of people do not know that the larger the gauge, you know, the higher the gauge, the smaller it is. Sometimes it's hard because it doesn't make sense. No? So by using this cross-sectional area, the greater the number, the bigger the wire, which makes more sense. The length, the wire mesh comes in rolls, wound into a roll, and usually smaller wire sizes, or in sheets like this one. This is flat sheets. The length of a roll is 100 feet, 150 feet, and 200 feet, while the common length of a sheet is 20 feet and 25 feet. The common width in the West Coast is 7 feet because they're limited by the tracking limits. You're not allowed to haul anything in the highway greater than 7'6". Because it's stacked, they say, okay, your wire mesh better be 7 feet. That way, if it sort of falls on the side, you still have some room, like 6-inch room. In the East Coast, the width is 8 feet, so they have a greater flexibility in highway width. Later on in our upcoming video lessons, I'll show you how and where structural wire mesh are used as stirrups and ties and reinforcing for flat plate slabs. This is very common in Singapore. In Singapore, instead of cutting the bars, bending the bars, they use wire mesh for slab. So because they comes in sheets, they will design what size they want, and they just drop it in the slab. Same thing with, they use it for column ties. They use it for beam stirrups. Because it comes welded together, it doesn't rock. You know, it's very good for precast beams because the cage doesn't rock. The next topic is bar supports. I want to remind you again, everything that we're talking about is all in the book, and really you need to read through the book and get all the details, because I'm skipping all the details. I want you to do that yourself. I'm just pointing out the highlights, what is very important to bar lines. Now we're going to look for the bar supports. Okay, bar supports. These are all the tables in wire mesh. Quite a bit of tables in wire mesh. If I, tells you W, plain wire, or deformed wire. Oh, there's a different size. And on wire mesh, you could pre-order them. You could specify what wire size you want, and what spacing you want. You could design your own wire mesh. In the United States, you could. Bar supports. Bar supports may be made of steel wire, precast concrete, or plastic, or even rebar itself. For example, in standees, Z-braces, and wall spreaders. I'll show that to you later. Basically, though, what you need to know about bar supports is the type of rust prevention. Rust prevention in bar supports are classified into several classes. First one is class 1, which is maximum protection. Accessories are plastic protected. They will have plastic tips, and they're used in situations of moderate to severe exposure or situations requiring light grinding or sandblasting. Class 1A, maximum protection, are epoxy coated, vinyl coated, plastic coated bright basic. So the wire is coated in epoxy coating or plastic. Those are class 1A, and they're designed for moderate to maximum exposure where no grinding or sandblasting is required. Class 2, moderate protection, are stainless steel protected wire bar supports. Stainless steel, moderate exposure or light grinding or sandblasting. And then the last one, class 3, no protection at all, bright basic wire supports. Just the bright basic wire, and it has no protection against rusting. Precast concrete bar supports are normally supplied in 3 styles. Plain, that is just the concrete itself with wires. That's the concrete with wires, so that they could use the wires to tie it to a rebar. And the other one is doweled, and I'll show these three items to you later. They're basically used to support reinforcing off the ground. In other words, on grade, not against form, but on dirt. All plastic bar supports are particularly useful in situations of moderate to severe exposure or where grinding of the concrete is necessary. If it's all plastic, and let's examine all these different bar chairs. These are all made of steel wire. The commonly used term that you will learn is terms like bar chairs, like BC, bar chairs, bolsters, SBs, that's slab bolsters. So bar chairs, when they refer to an item as a chair, it means it's an individual piece. When they refer to an accessory as a bolster, it's a continuous piece. So a slab bolster would be a series of legs on a continuous wire, like this one. But an individual one is called a chair. It could be bar chair, like this, short, no higher than 2 inches. Higher than 2 inches, they call it high chairs. High chairs. Continuous high chairs. Sometimes continuous high chairs upper. The U stands for upper. That's another term that you will learn. This means this is used between two mats of rebar. The bottom wires are placed on top of the bottom mat of rebar. Not the forms, but the bottom mat. That's why they call it upper. It's not a spacer between form and rebar, but a spacer between rebar and another rebar on top. So they put the lower legs on top of rebar, and the top one will support the upper rebar. Then you have joist chair upper, continuous support, all that. Let's see. In concrete, plain concrete becomes 3 inches by 3 inches, sometimes by 2 inches. There's different dimensions. We call it blocks. Sometimes blocks is spelled to make it easier, B-L-O-X. Sometimes we spell them as blocks. Write it down. So sometimes we refer to them as blocks. Oops, too many. Like that. This is blocks with wire. A combination blocks, that means a rebar going through there and another rebar going on top. This is a doweled rebar. The blocks has a hole. You detail a piece of rebar with a 90-degree bend. You put it in the hole and you use the rebar to support a mat of rebar higher up. All plastic bar support. All plastic, sometimes they have a clip. Instead of tying the rebar, you just clip the rebar on. This is a high chair. This is another high chair. This is a wheel. It's got a groove on it that you could insert it to a stirrup or a tie, and it becomes a spacer between the stirrup or the tie and the form. So they use that. That's wheel side form spacers, bigger side form spacers. Like they always have an opening in the middle, so you could insert it into a rebar. These are all plastic. Yeah, so you read through all this. You see, it's very interesting to know and see what is available in the United States. And it's also important to know where all these applications are made. The Manual of Standard Practice will show you slab bolsters are used underneath the lower rebar, and sometimes they're all slab bolsters, which means a continuous piece of support, or a combination of slab bolsters and bar chairs. And then the upper rebar is supported by high chairs. Sometimes, if there is no transverse bars, you will provide either a number 4 or a number 5 continuous support bars, which is rebar, and those support bars are supported by high chairs. That's shown like that. Like in this case. See, these bars are support bars, and the support bars are supported by high chairs. Joists, how joists are supported, how beams are supported. A beam can be supported by a continuous beam bolsters, which is placed underneath the stirrups, the long ways going along the length of the beam. Those beam bolsters are easily cut into small width, and sometimes if the beam is so heavy, the iron worker will cut them to about the size, the width of the beam, and will place them transversely. So one, and 5 foot later another one, 5 foot later another one. So instead of it continuously, it's transversely. It's easily cut off because the wires have a groove in them every foot, so you could just bend them and it'll cut off. This, I want you to study this. This is on a two-way flat plate, how rebars are supported. Study it carefully. Underneath, it describes the sequence of placement. But let's examine it. And let me get this highlighter so we can see. The first item is they lay down, see the direction, north, south, east, west. First one is they lay the east-west slab bolsters. Let's see, east-west slab bolsters is the first one. And which one is the slab bolsters? Like this. So all the slab bolsters, all this rugged thing on here, they lay down certain spacing. 4 feet is the common spacing. Sometimes 3 feet, sometimes 4 feet, sometimes even 5 feet. So first they lay down continuously, east-west direction. After they get it down, then they lay the rebar. Let's call it the rebar green. The north-south rebar is laid. That would be, let's see, let me see. I believe, I want to make sure, because it's 3D, it's kind of hard to see. All this black, number 2, that's the rebar. They lay it on top of the bolsters. They lay it on top of the bolsters, one span after the other. They lay it at the column support, at the column strip. It's got a bend, and they lay it there. And after that, they lay the east-west rebar, which is number 3. That's the one that's white. You notice both of them are now being supported by these yellow slab bolsters. You don't need to lay any more slab bolsters the other way, because now the first set of rebar is supporting this second set of rebar. Alright, and here's another one. At the column strip, it's got a bend. Usually at the column strip, it's got a bend at the support. And then of course inside is just straight. And here's another one. There's so many. Okay, after that, now we need here's some more north-south. I didn't see that before. All right. Then you put this number 4, which is another rebar strictly for support. Okay, let's see. Number 4, east-west bottom bar. Okay. Or I guess it's part of the. These are just support for the top bars. Oops, it's rebar, so we call it green also, but that's not part of the design. It's just a support to take care of the designed rebar. And these support bars, you could actually, you notice it's almost like it's continuous, and you only put them at the column strip. See, only at the column strips, there, and it's almost continuous. You could, the space, you could cut it away, break it, because really there may not be any rebar in between, so they cut it. But in reality, sometimes I will just run a continuous support bar. They may be number 4 or number 5 bars. And here's another one, all that. And you notice it's only at the column strip that you need this, because only the column strip will have negative reinforcing at the top. See there. On each strip, a minimum of 2, of course, is what you need, because 1 will not support the bar, 2 will. So a minimum of 2 is what you need. So, and all these bars now are supported by high chairs. You notice the high chairs underneath all of those bars? After they got that place, then they lay down the main column strip reinforcing on the east-west direction, like this number 6. Now you lay those down, and there could be so many of them. 6 at the mid strip, which is number 7. See, and then at the column strip, it's back to here again, and over here it's number 6 at the column strip. It's a number It's a number 7 designated as number 7 in the mid strip and number 6 on the column strip. So all those bars that you laid before, the support bars that you laid before, the number 4 and number 5 on high chairs, is now supporting the east-west design bars, the negative bars for the plot plate. And after that is done, now you put the north-south negative bars at the top, the 8s, all those 8s. All those 8s you put at the column strip. Here's another one at the column strip. Only at the column strip. Only at the column strip. So you can have that. See? There you go. So you have slab bolsters and support bars, which is number 4 and number 5 on high chairs. You notice that on the north-south direction, your support bars is only, like this one, let me use yellow just to distinguish it, only at the mid strip, only at the mid strip, because there's no support, nothing on here, only at the mid strip you need those support bars going the other way. In the north-south direction, it's almost continuous. On the east-west direction, it's only at the mid strips. You need them. And they're on chairs also. And it's used to carry the north-south negative bars. That's it. So you now have the slab bolsters, support on high chairs are the ones you use. If you're detailing this and you got all the bottom bars as shown in the drawing and all the top bars as shown in the drawing, but fail to recognize that you need slab bolsters, then you're detailing, you're off, you're short, you don't have any support bars. So there's more to detailing than what is shown in the drawing. The engineer never designed support bars. That's the detailer's job. So it's your decision whether to use a number 4 or number 5. As you gain experience and you've talked to iron workers, you build a rapport with an iron worker, then they will tell you if the slab has this much span, like 30-foot span or 30-foot bay, use number 5 support bars at 4 feet on center. But if the bays are only 20-foot bays, go ahead and use number 4. So you learn this as you go along. But flat plate or a two-way slab, you need to know when and where to provide support bars on high chairs. That's how important this is. So there's a big chapter on this MSP on this one. I want you guys to study this. All right, and maybe this is a good place to break. Okay, let me move and see. So, looks like we may be able to break this MSP book into 2 parts, 2 video lessons. So there's a lot of reading. That's just a flat plate. Here's a two-way flat slab. Tells you, get a highlighter in color so you could see exactly where all the bars are going. All the bars, and then here's a waffle slab, where to support the waffle slab. These are never taught in school. This is what you're going to learn here. And how to support slab on metal deck, all that. Big chapter on bar supports. Because these are the hidden rebar. Here is a standee. This is a standee. It's made of rebar. So when I'm saying accessories can be metal, plastic, blocks, and also other rebar. So here's another standee. And the fabricators like to do this because this is just one plane and then they spread it apart. While this one is in 2 planes, so this costs more to fabricate than this one. And here's the candlestick blocks I was telling you about, where the block has a hole. You detail something like this, you insert it, and it now carries the top part. like that, like that, that, yeah. So gives you all the bar support. In highway bridge, where do you support? There. So many things. Where you could use blocks to support over formwork. This is a bridge. It's all here. It's all covered here. So it's a nice manual. This manual is not available in the Philippines. And we have it. It's available to you. Each one of you can make a copy of this. We have it in diskette form. Ask Brian. When we bought the book, we bought several books together with several CDs. That way you guys could put it in your computer and read it through your computer. Have it ready on your computer, just like I have it on my computer. I read it through my computer. All that. All right, so this is where we're going to break, and the next lesson will be the second half of this Manual of Standard Practice 2009. All right, thank you very much. Bye-bye.